that is. Oh, that makes
There it
sense.
goes.
That looked like it took. I'm noticing up in the, are you guys getting in the top left corner a little lock with an E in the middle of it?
Yeah, the encryption.
Yeah, I do.
I haven't noticed that before. Is that new?
I don't know.
It came out like about a month ago, I guess.
Takes the NSA now 10 seconds more to decrypt what we're doing. Well, on my side, let me see if I can pull up the Slack channel. I continue to make a little bit of progress. Everything's not done, but I have successfully got my front angle sensor redesigned, so I'm detecting the angle right over the shaft of the front wheel and creating publishing, I guess is the right verb, a ROS topic of that angular value. So I've been going through Matt's main ag code looking for what do I need to change in that in order to load that up on my side so I can get going. So I was trying to find that code. I thought I had posted it in Slack, but bear with me a second, guys. I may have not pressed send on that this morning or last night. Let's see if I can find it another way. Well, I was hoping to use some time. I don't know if you're open to it, Matt. I was hoping to use some time to walk through that really quickly and have you comment on, am I thinking about this correctly, and in the sense of which sections need to be changed in order to re-implement that code on my, on my platform.
Yep. And then can we make that editable? So if there are some ideas or things that need commenting, we can put that in there.
I see on the Slack channel and Lawnmower channel, you have a link that says code here, and it gives a link, the last thing that was posted in there. So it's got a picture of your front end, and then it's got the link saying, here's the code.
Yeah, here, thanks for that. That's pretty darn close. I had added, share my screen. Just confirming, can you see my screen?
Yes.
So I had gone through the code here and put a starting comment in here. So like this is implementation specific start and implementation specific end. I didn't have a better way of doing that, but it was basically to signify this code, this is an easier one, right? My view is something in this has to change for my implementation. So Matt, restate your last comment. You said, can we put a link in
No,
that?
you're doing great. If you want to take notes on there, just so we could make it editable, so we can improve the documentation, so the next people through can understand it a little bit better. And
yeah, cool. Yeah, both here. I'll maybe put some words down in another document to supplement that, but just at least start with, we all agree, right? This is implementation specific and that's got to be updated for particular implementation. The next one, the whole ticks traveled thing, I still have to think through because I have an encoder that's effectively producing the, I think you call it angular, well, you don't call it, but down here later, you've got linear x and angular z. You use the ticks in order to calculate linear x, right? Linear velocity x.
Yeah, that's the speed sensor.
Yeah, so my in my configuration, you know, I'm was intending on publishing that value. So this statement would be a little bit different.
So this one that you're pointing on now actually is the command velocity message coming from the ROS system. So this is telling your robot how fast to drive.
Yeah, that's the target value.
Yeah.
But then you calculate your variance. That steer velocity is below steer, as I recall.
So it's calculated in the loop. If you want to see how we calculate the velocity.
No, I think I'm getting down to, you calculated in this program. I think I'm going to just be able to subscribe to it because my odometry thing is a little bit different than yours. I won't need that calculation.
Yeah, I'll just stick to the concepts because people may use different sensors and they may have the setup a little bit different, but everybody needs to measure speed. So however you want to measure speed, if you have a pickup sensor like this or a pulse counter or a Hall effect or like you have a quadrature encoder or a regular encoder.
Right.
The principles are all the same. It's you want a distance measurement and then you want to know the time, so speed, distance over time.
And so for me, I think I'm going to subscribe to a value and put it in this value.
Yeah, like you in here, you almost have 2 or 3 different programs running on different systems for your setup.
Right.
Yeah. So this one would go into your main controller that's receiving your speed from your left and right, and your steer.
So let me go back to, we were talking about and here I had a question. You have 2 of these.
So the first one describes it. It whatever that's called, instantiates the variable.
How do you get 2 void statements though with the same name and get a clean compile?
That's a good question. I don't know. That's bottom one here is the function.
I just hadn't seen that before. Do you?
What one is the function prototype. The top one's the function prototype. It's got a semicolon after it. So it's just so the compiler knows what it's compares to down below. So the bottom one's the code, and the top one is just saying this is a function called command callback. So the top one's just a definition on line 66.
There you go. Spoken like a C++ guru.
Yeah, yeah.
So we talked about the left ticks. I thought all this would survive, without, issue. I added just some reference to this simple Kalman thing. I mean, these settings, actually, I guess I don't understand this. What are you feeding? This is just like a definition statement then for the Kalman filter?
I think on the README, he kind of explains how that setup is. or if it's a C++ question.
No, I'm trying to find where else do you use that. Yeah, this is what you're sending it. You're sending it your angle sensor. Yeah, that's what that's what I was just wondering what you were. And then your angular Z, at this level, what's the leftmost value that you would get for angular Z, angular velocity Z? Is that -1 to 1, or is this, because here you have, do you happen to recall?
I don't. I think it's 0.3 to 0.3.
Angular velocity is going to come back in radians per second, or that's what Ross wants to see it as. I don't know what you buried down in here. I'm not sure what you're defining that as. But right above where it says linear velocity x should be in meters per second, and the one that says angular velocity z should be in radians per second.
But it's coming in through this, which is your command velocity.
Yeah, so that should be in radians per second then, if that's where it's coming from. So it's based on whatever the limits are set at in Ross as to whatever it's going to be. Well, actually, no, because if you're treating that as a steering angle as opposed to a rotational velocity, then I guess that doesn't apply what I just said. Since the TEB planner is substituting that for something else, it's not in radians per second. So I don't know what his limits were on that.
The reason I ask is because my angular Z at the moment from the joystick node is 1, full left is 1 and full right is -1. And I was just wanted to verify that that's what is the range coming in here as well. Are you looking something up, Matt? You're on mute, by the way.
Yeah, so you can start up your joystick and then just move the toggle left, right, and then you can do Ross topic echo on your command velocity, CMD vel, and you'll see the range that you're publishing.
And I've done that, and I know mine is 1 and -1, and I was just trying to verify that because I didn't quite understand this steer angle degree. I mean, this gets you to 57 and -57, and I was just trying to get my head around the math and wondering how, because I actually concluded that you're probably you have a different input than I do, is what I was thinking. And I was just wondering what that was. We could try it, see if it works. And then the 0 to 60, I don't, let's see, I didn't put any questions there. I was,
my thought is that 60 means 60 degrees. So up above where it said convert to degrees, apparently it came in thinking it was a value in radians. It converted it to degrees, and this map function says we're going to map the steering from 0 to 60 degrees is what that's That's the way I read that. So I'm guessing where you're saying it comes in, yours comes in as plus and minus 1, and that's probably not what Matt's is doing right now. Is my thought. I'm guessing he's got something between his joystick and this thing, because somewhere you have to have a program that says take your joystick value and convert it to command velocity. So there's probably another program in between there that's doing that. So my guess is the value coming in is a steering angle in radians, and then the one command says it converts it from the radians and converts it into degrees, and then the map function just assumes you're going to scale it to plus or minus 60 degrees, I think is what's happening there.
Okay. Moving on down. This statement needs to change for me because that's coming in a different way. So we know that would be whatever is the way to get the angle sensor in. Although I didn't understand this, I wasn't intending on changing it. So you've got some code here about steer smoothing.
Yeah, and that's probably specific to the sensor that I'm using. I'm using a potentiometer and then reading that value, where the way that you will read your sensor may be different, your magnetic sensor.
So
that would be implementation specific or per robot. Whatever sensor that you're using to measure your steer angle, how do you read that?
So is this where you thought this needed to be smoothed out, and you had a mixture of this Kalman filter plus these things in addition to the Kalman filter?
Yeah, that 166 is just reading the analog signal.
Just out of curiosity, could you have just fed that value into your Kalman filter instead of doing these mathematics?
Again, this is part of the Kalman filter. So at the Kalman filter, you'll put in your measured value, and then you'll put it in an error measurement, estimate of error, to get a predicted value of actual. So those go into the Kalman filter.
Line 172, there is a scaling function. So it says take the value read from the A to D and divide it by 1024. That's because there's 1024 counts in the A to D, and then you multiply them by 100. So I assume that's scaling it to 0 to 100% of what that line's trying to do. So apparently down below, it's looking for 0 to 100%.
Okay. So if I'm happy with my angle sensor, you think I can avoid
this whole section?
These items.
Yeah, and even line 166, you don't need that.
Yeah, I have to replace that with however else I'm getting that into there, right? Instead of an analog read, it would be a subscribe situation. Max steer, this is that's down here, right? So I'm keeping that the same.
Yeah, limit the effort. And I found that useful. There may be a better way to set this up, but hopefully as more people look at this, they can come up with better ways. But limiting how much power you use has been helpful. Maybe there's a way to do it dynamically or some value in that. Or measuring, like one of the things that Jim mentioned was if you're commanding your motor to move and your wheels aren't moving, to put a time around that or to put a check around that.
And then here you've got, I mean, I would say the neutral setting is, for me, got to be clear, and then the PID settings are got to be specific. Any of these others you think are implementation specific?
I think those are, like you mentioned, for the velocity control.
Like the KI timeout?
Implementation, that's all part of the PID.
So I was thinking I would have this thing up on blocks, you know, and then try to somehow do steering and transmission at the same time. And then take it down off blocks. And the first thing is to get it straight. And the second thing is to start to work on the PID settings. Does that seem to make sense?
Yeah, actually, the lawn tractor in Argentina, we just used these settings and drove it. We had to find the steer left, steer right, and steer center. You know, like when we first took it out, we tried to get it close to center when it was on blocks. When we went out and drove it, it was kind of, you know, bending to the left a little bit. So you got to adjust the center point. But after that, then we just drove it around.
But you kept the PID settings.
Yeah, surprisingly.
Okay, no reason to break that mold.
You may get different mileage on it.
And then the rest of this, I mean, then now this is back into velocity, right? When you were in Argentina, any comments on how you went about figuring this stuff out?
Yeah, so this one's different. This one is for a servo motor controlling the velocity.
Right.
So one thing we can do, I was working on down there is like C291 steer effort target set 2100. Those maybe be better to be variables that we call out. The implementation should be in one section, like a setup section where they're variables, and then we can adjust those. But your position of where your servo motor needs to be may be different, depending on where you mount it, the length of your mounting arm, and then the lever.
Yeah, I can make those variables. I think that's as far as I got when I was reviewing it. Left tick smoothing, this is about your odometry. Well, I don't want to take up any more time here. I mean, thanks for going through that with me, and it just helps me understand the code a little bit more and figure out how to make it apply to my particular setup.
So do you have the lawn tractor simulator running locally?
Haven't done that yet, no.
Okay.
You want to talk me through that? What is that? What do I need to do to make that happen?
It's out on the GitHub account under the Ross Lawn Tractor. There's the install steps.
I'm going to
just you can do some things like you could start the Ross Lawn Tractor simulator, and then you can start up RQT, and then we could go over how to do robot steering, how to plot your left-right values, and then when you move the robot steering, when you have the simulator going, you'll actually have feedback on that.
So when you say it's out here on GitHub,
yeah, the top one, the Ross Lawn Tractor. And so this is the simulator and the base station software for the lawn tractor. And here's a local install guide that will install it locally on your machine.
so what you're saying is go through these go through these prompts?
Well, if you want to, I don't know. I like the simulator, and then you can play around with RQT and you can do different things running on the simulator to make sure that portion of your software is working, and then adding the hardware. So you can break up the complexity a little bit. This one doesn't have the pure pursuit one. We're still working on that branch, but this one you can still run RQT, robot steering, plot values, go through that whole process. So the concept is your robot is sitting there just listening for command velocity messages. And then on your laptop, you can drive it around with a joystick. Your joystick is sending your robot command velocity messages.
Yeah, that'd be cool. It's easier to, I don't run over any cats if I'm in the simulator, right?
Yeah.
It also makes sure all the mechanics of it is working at least, right?
Yeah.
So all of that is between that command and this one loads it and this one runs it is what I'm picking up.
Yep.
Okay. Add a new Catkin build source. I mean, well, I can keep it in my current Catkin workspace.
Yes. You can. Or you can put it in its own workspace. Because you may, once we do this next update with the Pure Pursuit, you may want those changes. And so you could just delete that workspace with the simulator.
And this is again on the, this is not the lawn tractor version of ROS. This is the laptop, right? That's going to run RQT.
Exactly.
Yeah.
Yep.
Yeah, that makes sense.
Yep.
So that's what's going on in my world. Thanks for letting me take time to go through that. Jeff, what's going on in your world?
Okay, I think it's working now. I was complaining last week sometime about I got this new computer at work that was the from Logic Supply, I think is the name of the company, and I couldn't get the CAN stuff to work. Well, just here recently, this is the Linux side that's talking to this little adapter right here, and the Linux side is generating this message and the -G1 that's in there, which it's not going to focus. -G1 says put a 1 millisecond delay after each one, and over here is the messages that says the CAN dump. So the ones generating them is coming back out. And according to the number, which you can't see, the fourth column is an 04, which means I've sent 64 million packets since yesterday afternoon with the thing, and it hasn't locked up. So here's the receiver side, and they're just cranking along, and the time there says 0.001 as opposed to there's 3 zeros and a 1, which says it's like a tenth of a millisecond, even though the Linux side says to put 1 millisecond in when it transmits. So I don't know if somebody's got a timer screwed up there, but it looks like the values, the way they're calculated here, really are real values. If I put 100 milliseconds, that number comes up to 0.1 something. So anyway, the fundamental hardware that's in there does seem to run at high speed. So then it's got all the Python stuff on top of it that I can't figure out. So I'm at the point now where I just need to sit down and write a ROS driver so I can send the data in and out of the thing and see if I can get ROS to do that same type of stuff. So that's where I'm at on that project. So even though I was saying it was just a total piece of crap and it doesn't work, it looks like if you play with it enough, maybe you can make it work. So we still haven't decided if it's going to be usable for what we want. So back to my home projects.
Doesn't sound like they had a very good implementation. What implementation guide? So was it a software problem or a hardware problem?
Partly it's my not understanding Python because they've got a GitHub. You can go out, it's a public GitHub. It's got all the code in there, but I don't understand all the funny things they're doing in Python. So that was one of my big problems there. Another problem I had was I would run the thing and try to run at the higher speed. I was looking at it with my microchip CAN bus analyzer, which is a little $60 thing I bought one time for Microchip. And it's really just their chips put in a plastic box. There's really nothing special about being an analyzer or anything. It turns out that was dropping messages. So I thought their product was bad. I thought the Logic Supply product was bad, but it turns out my Microchip one was dropping messages. So when I look at it on Linux, I can see they're actually coming out. So it's just a combination of lots of things, trying to get things to work together, and some of them work and some of them don't, and I'm trying to blame the wrong thing. So now it's just down to the point where I got to go look through all their Python code. They keep trying to help me out on all this stuff, which they say, oh, well, this will do auto baud rate detection. Well, I don't want it to do that. I want to say, this is the baud rate, leave me alone. And then it says, oh, you can just type in this and it'll automatically figure out number of bytes and figure out the ID length. And well, I don't want to do that. I just want to tell it, you know, we're professionals here. We want to tell it what it's supposed to be and have it work. So it's just going to be a matter of going through that and trying to figure out which of the functions, which of the helpful functions they have, we really need and don't need. So anyway, that's just something to be worked on. The rest of the day, I'll play with that, see what happens.
That sounds awesome. It sounds like you're raising tickets with the OEMs and they're replying to you. That's always a good thing.
Well, no, so far I sent something to the sales guy because he said, oh, how's your evaluation going? I wrote back, says, well, I need to know this. Oh, well, you can call customer support anytime you want. So that's where that got left right there. And we still have the issue that if it seems to come up the interface comes up automatically when you boot the computer. And if you're set to the wrong baud rate, it crashes your entire CAN bus. So until you go out and initialize the thing, nothing runs. And I don't see any way, so far, I haven't seen any way to change that. And it could be that the luck I've had everything else, it could be it's there and I just can't find it. So that's something I'm gonna have to go back to customer support and say, how do I fix that? Or am I mistaken, or is that what it's really doing? So anyway, well, I'll let you know more on that next week, how that goes. So back to my, what's that?
Speaking of hardware, I have to say though, so Matt, told me that I was too slow of a programmer, so I needed to get a new IBM, Lenovo ThinkPad, and I've been very happy with it. I mean, it was an eBay purchase for, what was it, Matt, $500 or $550, something like that, and I made it a dual boot machine, so it's got Ubuntu and Windows on it. And, it hasn't, as Matt promised, picked up my speed of coding, but...
that's what I was going to ask. It didn't solve all your problems, but apparently not, huh?
I'm still a slow coder, but I can run 6 Platform IO compiles pretty quickly.
So back to my home projects. So a couple nights, or last night, I was going to look at adding printf to my microcontroller code, and since I'm not using the Arduino stuff, I don't have all the stuff built in. I went and looked at it, and yeah, I could probably figure it out, but I've got a different way I'm doing it right now. So instead of that, I pulled the top off my super servo and soldered a wire in there so I can get the feedback voltage out of it. And I pull it out and I can hook it up to a meter and I can see it move back and forth as I move the wheels. And I see I'm going to have the same problem Al's going to have, the fact that I thought the way I did my mechanical system that I would get a centered steering out of this, but I'm not, since the servo's connected directly to one of the 2 wheels instead of connected in the center. I get the nonlinear, I get the Ackermann effect is what I'm getting out of the servo. And I haven't decided yet how much of a problem that's going to be. Number one, I can just choose to ignore it completely and see what happens. But if you go on the center steering, like you're doing on the Cub Cadet, so where Matt's reading the position of that gear, then it's going to be linear back and forth. And since Al is right on that front wheel, he's getting the Ackermann effect on that, which is the same thing I'm having right now. So hopefully fairly quickly I'll know how much of a problem that's going to be, and no, we have to worry about that at all. And somewhere I was just thinking that we have some code out on our repository that takes a steering angle and converts it to the left wheel angle and the right wheel angle. So it'd be a matter of going backwards on that to figure out what the transfer function is to fix that issue. So basically when you say, I want to turn at 10 degrees, you have to figure out, you know, say if you got your sensor on your left front wheel, then you have to figure out what's the angle that that's got to be at and control to that. And then likewise, when you read it back out, you say, okay, here's the angle it's given me, and you have to convert that back to whatever the center steering value would be. So I'm going to start off just trying to ignore that and see what happens on that. And I did notice I'm getting, it goes from like 1.7 volts to 2.6 volts, and which isn't a lot of range, but when I divide it out, I think I've got a 12-bit A to D. So I think I've decided I get 248 counts one direction and about 500 counts the other direction. And I don't know if that's enough resolution, but it's a lot more than trusting that super servo to say, go to this angle and expect it to do that, because I don't think that's going to work. But this will let me get a feedback from that, so I could use, say, here's the angle we're actually driving at. Was the other thing on that? Oh, and that's where I noticed that, as I say, it went from 1.7 to 2.6 volts, but the center was at 2.4, which means I've got 0.2 volts one direction and 0.4 volts the other direction. So it's that much difference between the fact that it's not a linear curve and it's not centered. So I'll have to do some more work on that. A couple nights ago, I grabbed a USB cable and cut it off and soldered one end onto my microcontroller board and plugged the other end in my Teensy that's on my remote control receiver. So that's got power. So I just got one switch now on the robot. I turn it on and it powers up everything. It powers up all the low level stuff. So all my motors are powered and my microcontroller, my remote control and all that. And one of the next things I'll have to do on that is figure out, I've got a Raspberry Pi in there right now, which I may replace with that NVIDIA Nano board. But either one, I'm going to have to figure out how to power that. So I'm going to have a separate power supply that takes the battery voltage and converts it down to the 5 volts that it wants, and then decide if I'm going to put something smart enough to power that up and down on its own. Or for the moment, I just put a switch on it. So when I flip the switch on, the converter comes on and powers it. So I guess that's where, that's kind of where I'm at on my hardware journey right now. So I'm running out of things to play with the electrical and the mechanical stuff. So hopefully I can just switch over to software and say, okay, now make it actually do something fun now. So that's, I'll know more on that next week. So if I don't watch TV all weekend or sleep all weekend, I might get something done. Well, because last week over the holiday weekend, I put everything off till Monday, and then Monday afternoon I started working on the electronics and soldering parts on the board, and that's all I got done over the whole holiday weekend. So that's all I guess. I guess that's all I got to say at the moment.
Jeff, on your steer angle, the way that's mapped, at least on the Teensy, is non-symmetrical. So your 0 to left and your 0 to right can have different ranges. It's still linear. I don't know if you're going to try to do a curve fit on that, but that's the way that's set up on that Teensy code.
Yeah, it's the fact that it's not linear. The fact that it is a curve, it might be an issue, but I don't know. As I say, if we do like you did and just simply say, going to the right, here's the slope, and going to the left, here's the slope, that may work. That may work just fine to do that.
Test that first before the advanced.
Yeah.
The easy stuff.
My experience with the Super Servo and having it on a test bench with a weight scale was, again, I'm not the mechanical engineer, but if I said, I wanted a PWM signal, and every time it would go to that same PWM signal, the torque that it was producing, that was consistent. The position was not consistent at all. So stated another way, if I didn't have a weight scale on the Super Servo and I said go to 1900, it might be way over here, but then with the weight scale and said 1900, it would consistently come back to the same position and deliver the same amount of torque. So it's just interesting how they designed that. to not be positionally consistent, but rather my hypothesis is they designed it to be torque consistent. So for whatever that's worth, I think it's a great platform. It's almost like, though, I'd like to rip out the the electronics and replace it with electronics that were positionally consistent as opposed to the way they've got it.
Well, that one website I found where the guy was hacking on his Super Servo, if I do the same thing he was doing there, which basically he takes out the feedback voltage and runs it through a separate microcontroller. So like Matt has a separate microcontroller hooked up to his, he was reading the feedback voltage into that and then controlling the PWM out to the motor. So basically he was converting the motor into just basically just a motor with a power driver on it. So he was doing his feedback inside of his little microcontroller that he added on. And I think the whole problem with the Super Servo is that they just don't have enough gain on the feedback, so it doesn't try to track as close as it should. And this other guy was pointing out, he's saying how noisy the feedback is. So it could be the feedback was noisy enough they just kept the gain down so it didn't jitter. The fact that they don't seem to be selling the 200 model anymore, but you can buy the 300 model for like $20 more or whatever, it could be that that's why, because they actually fixed it. Because as far as I can tell, it's the same exact gearbox on it, yet they claim it runs at a different speed, and they may have said it had a slightly different torque to it or something, but I'm thinking it's the exact same gearbox, so they probably just fixed they just called it something different, and they're just reselling it as a different model. But without buying one to try it, I don't know. I haven't seen anybody that's evaluated the different models to know if that's the case or not. So my first thing that I'm going to do, I'm going to treat it as an RC servo and send it this pulse width and expect it to go to that angle. And at that point, I have the opportunity to read the angle back and see how close that is, so I can compare it to see what that's doing. And then if I want to, I could put a feedback loop that takes the steering and then controls the servo one way or the other to actually get it right. But I'll just do the simplest thing first to see what I come up with there.
Cool. Anything else, Jeff?
That's all I can think of at the moment.
I like the sleep and relaxing part of the weekend. I want some of that too. Matt, anything you want to share? Where are you? What are you, above the equator or below the equator?
Arlington, Texas. Still here.
Put that up on the map. I don't even know where that is.
DFW, right in the middle. I was curious, Al, if on that platform I/O with multiple Teensy's, are you able to flash now? Remember how it wasn't letting you set up different environments to flash to Teensy 1, Teensy 2, Teensy 3?
So what? It's a bit of a journey to get there. But yes, I have to. I wrote a small bash script to disable the USB ports that I'm not programming. And so it takes 2 bash scripts for me to compile something, one to disable the ports, run the compile, and then the second script to re-enable the USB ports for everything, and then start the launch file if I can get. See if I have that handy. Oh, come on, where is that? I'll show you what that looks like. So turn on screen sharing. So this is one script that I run, and it effectively turns off these 4 USB ports. And then, although this is commented out, I uncomment the line that says, okay, unbind, turn off those USB ports, and run the compile. And then the next, then the next one basically reverses that back out. So now it's binding those USB ports, and then runs the launch file. And then inside the platform.io.ini file, there I have like different environments. So saying which Teensy I want to focus on. Let's see if I can find that. Here it is. So at the moment, I've got one platform INI file and 1, 2, 3, 4, 5 different Teensies that I might be hitting on. And so in that platform INO run command, I say, hey, fire up that environment. And so then it goes to, say, the steer motor. And so that's a Teensy 3.5 versus some of the others are Teensy 3.1s. And goes to that upload port, which I've got the UDEV rule written for.
Okay, so do you unbind all of your USBs and then run the platform and then bind everything back up?
Yeah.
Okay.
And that I have instructions or notes that I took on how to do that if you're interested, because getting these hardware, I forget what the exact, I'm going to call them the Symlink, even though it's probably not that. Figuring those out is a bit of a drama, but yeah. So in this case, at the moment, if you looked at my USB hub, I have whatever that is, 1, 2, 3, 4, 5 things plugged into the USB hub. When I'm about to program something, I have to decide which one I want to program, which is not hard because typically I'm working on one thing versus another, not 2 or 3 things all at the same time. So you unbind the 4 that you don't want, you leave the 1 that you do want bound, and you run the platform IO focused on whatever board type that I'm looking for. Clunky, but works. It's fantastic now that I got it worked out. Because before this, it was a royal pain in the patooski. And I could do that, sitting at the kitchen table and the tractor's out in the garage.
That's pretty cool.
Yeah, that's what's really sweet about it.
So what is the short definition of what Platform IO is or does?
You want to take that, Matt? I don't know from a programming, but it's like an IDE, but it allows you to upload it compiles your Arduino code and then uploads it to your device from a command line.
So it actually has the Arduino IDE built into it, or it does understands the same code?
Yeah, understands the same code. And you can use CMake. So like inside of ROS, when you do your catkin make, you can have it upload your information to your Arduino. But this one I got from the Lino robot, but it just allows you to SSH into your Raspberry Pi and then upload your code, make changes, upload.
Mine, since I'm using that eval board that's the ST Micro one, they've got a separate programming utility. So what I could do is I could load that, say, on my Raspberry Pi on my robot, and then from my whatever I'm developing on, I can compile it and then do secure copy to copy it over to the robot and then execute the command line there to program the thing. So I'm just wondering if this thing was just doing the programming for you or if it was doing something else.
In my case, Yeah,
I think I can piece something together. I think so.
yeah, the lawn tractor file is just the lawn tractor is just compiling and uploading for us.
Yeah, so I mean, it's a productivity tool to make it easier to program the microcontroller and multiple microcontrollers. I mean, for me anyway, that's the effective use of it. It was a sweet find. I think Matt turned me onto that.
Thanks, Juan.
I'm sure there are others.
Been a lot of help.
Anything else, Matt, you want to share?
One question, I know it's hard, but imagine like a year ago and then where you were and then where you are today. What would be some ways that we could make that path shorter or make it easier, or where you need to go?
I think Jeff had a really interesting idea once. He pulled up that smaller electric, I don't know if it was a child's ride, but it was a smaller platform. I mean, one thing would be, instead of having something that would fit on a small trailer, but if it would fit under your arm. I mean, a little bit more robust than, say, a radio control car, but Jeff, you remember that $300 or $400 electric car thing that you pulled up on eBay?
Yeah, it was some child's ATV type thing, and so I think what you're saying is if you just simply had a starting point, a mechanical starting point, is what it really comes down to. Is if you had something that's closer to something that would be ready to go, as opposed to modifying a garden tractor or a full-size tractor or building something from scratch. It would be nice to have something that you can just start with and say, like, even if you get that electric ATV, you still have to add some kind of steering on it. So you still have to put some kind of steering motor. But if somebody came up with a standardized way to do that, the one YouTube video, the guy had just put a linear actuator. So he took off the handlebars and put an arm sticking out the side, and they just had a linear actuator pushing back and forth on that to control the steering. So that might be a reasonable way. If you could say, buy this brand of ATV and then buy this linear actuator and bolt it on like this, and then just go from there. That might be a way. But yeah, you do have a point that if you can just point to something that says, if you start with this, you're pretty close to what you want, as opposed to piecing everything together.
I mean, so for me, I like the fact that at least we're focused on a lawn tractor, because I can see the use cases for it, right? But if you just wanted to get something out and driving and accelerate that process, it would make that smaller, not as small as an RC car, because I don't know. My inclination is, rather than just promoting an RC car, I would rather think the ATV would be another option.
And the other thing I keep thinking about is I keep piecing my stuff together. I'm thinking if I'd make a printed circuit board where I put my different modules onto it, and not necessarily design it down the point where you have to solder individual resistors and transistors onto it, but say if you have one, say those little $2 ARM boards, you just have a spot on the board to plug one of those in, maybe plug two of those in, and then plug in one of the power supply modules. And then if you come up with a list of things like, say, it's already been started where you guys are using that relay on your Raspberry Pi, the relay board. If you just have a list of boards that says, here's a list of relay boards, here's a list of opto isolator boards. I found some of those on eBay, and just ways to take an off-the-shelf interface board, and then you just got to wire the thing from the board to your whatever your controller is. That might be a quicker way to do that too. But the problem with that is you can't really say, here's what it's got to be, until you get something that's actually running and say, here's enough functionality to say, okay, now I'm going to go lay out the board and make it so somebody else can use it. Because otherwise you get it so far and then you want to add something else on. Well, it's either too late or So if you can figure out what to piece various modules together to make that work, might be the way to go on that.
Or, I mean, you seem to be able to rock up to Buenos Aires and get those guys going in, what, 10 days? It's just 10 days of Matt's time.
Yeah.
Well, you can just sign up, and then everybody says, "Matt, come over to my house and build this for me." And
You know,
they'll keep him busy.
because that worked good. That worked well.
So after going through that experience, what do you think would have helped you, or what do you think would be for the next time somebody wants you to come help them? How do you think you would approach that?
That's one of the conversations we were having, and like your suggestion with the board, just making that easier to plug in chips, and then have some, like you're saying, maybe if we had like 4 PWMs, or we get a different thing that's easier just to plug stuff into instead of having to do the voltage dividers and then try to do all that at the component level. And then the second thing, which like Al's saying, like somehow going through the ROS tutorials and then somehow having a smaller platform. So you just, whether you have a joystick and you're driving a little teeny robot around, it's exactly the same thing as driving the lawn tractor around, but it's a lot easier to work on and work through those things instead of, getting a big machine all working. But it's maybe harder to motivate yourself to play around with a little teeny toy versus a bigger machine and how you're doing it.
That's a good point.
Having right now we're trying to do is get all the software together so it makes it a little bit easier. We're still struggling with the install on the Pixie driver, but like LinoRobot did, he's just got that one bash script for the ROS Me, and man, that just makes it so easy to install ROS. And so kind of looking at those things, how do we make the install easier, and then how do you work up to this? Once you have the lawn tractor, I think it's easy in a person's mind to see, okay, I've got this electric power steering, I can take that and move that to a tractor. But if you just have this little teeny toy, $100 toy running around your kitchen table, maybe in the mind it's not as interesting. Still extremely useful trying to get ROS going and driving it around, but
I'm glad you say that because I don't know. But hopefully in a weekend or two I will. I've got to go fight through how to simulate it. Hopefully that won't be a painful process. Anything else, Matt?
no, that's good.
Jeff, you good?
I think so.
Well, good luck on your canned stuff, and may your day be filled with 10 million more, or I forget what the number is, but 10 million more packet transfers, uninterrupted. May your packet transfers continue uninterrupted. I'll see you guys later.
Great weekend.
Okay, see it.